Dear students, in this video, I take the topic array processor from your chapter 9, pipelining and vector processing. So, the array processor is a processor that performs computation on large array data. Array processors are of two types, attached array processor and SIMD array processors. Attached array processor means we have a general purpose computer and we have additionally attached one more processor, auxiliary processor for a specific task. So that is what attached array processor is. SIMD array processor has SIMD single instruction multiple data stream organization. It manipulates vector instructions by using multiple functional units. Multiple functional unit means there are processing units more than one and there is a single control unit. So here we see how the attached array processor is uh, organized or arranged. Here is your general purpose computer and here is an additional processor which is attached array processor. So both these will communicate with some input output interface. So they will give some input to this interface and it will go to the general computer in both the directions. Here is a local memory of attached array processor and here is the main memory of your general purpose computer. These two memory may also communicate. That means some data can be sent to main memory from local and from main to local also. This attached processor communicates with its own memory and this general purpose computer communicates with its main memory. So this is how the arrangement is done. A general purpose computer VAC 11 is attached with FSP 164 Max. So this is an example where this attached array processor is implemented. VAX 11 is the general purpose computer and this is attachment. And this is how it is organized. Here we see SIMD single instruction multiple data array processor LEAC 4 is example of this. Here is only one control unit and its main memory. And there are many processing units. So processing element 1, processing element 2, processing element 3 up to n processing elements. Each processing element has its local memory M1, M2, M3, M4. So these local memories can communicate with this main memory. These processing units receive data, control or command or instruction from this master control and there is multiple data set. So if say I want to perform A1 plus B1 and goes to C1, A2 B2 goes to C2, A3 B3 goes to C3, and such thousand data is there. And if there are 10 processing unit, I can distribute 100 to each. And if there are 100 processing unit, I can distribute 10 to each. So each of the processing unit will perform the single operation on multiple different types of data and will store their results in their local memory, which will be later on combined to get the final result. So this is how SIMD array processor is organized. This requires more hardware and can be costly from a general purpose simple computer. Pipeline is a middle way, little bit less, little bit costlier, and able to give fast output. This is costlier but will be producing output very fast and is able to handle large amount of data. When here we say array processor, it means that it can work on vectors. Vector and single dimensional array they are similar terms. Vector processing is done through array processor in these two ways, SIMD array processor and this attached array processor, and also through pipelines. So pipelined vector processing we have studied in our previous video. Here is array processing organization. These are the references. Thank you very much.